Hello, you are welcome to our SHS 3 Core Mathematics lesson brought to you by the Center for National Distance Learning and Open Schooling, CENLOS. I am Uncle Ben. Our topic for today is area of prisms. By the end of the lesson, you should be able to calculate the surface area of prisms. An area is a space that is contained in a two-dimensional figure. Surface area of a prism is therefore the sum of the areas of all its faces. One way to calculate the surface area of a prism is to use the net, since the net is a two-dimensional representation of the prism. Now, to find the total surface area of a prism, we find the area of each face and add them together. Hence, the total surface area of a prism is equal to the sum of areas of the faces of the prism, and that is the area of the net of the prism. Let's look at the total surface area of a cube. The cube has 6 faces of equal area. Therefore, the total surface area is the sum of the areas of the 6 equal faces. The figures you can see represents the cube, indicating its size. We have the left side and the right side. We have the top and the down. We have the back and the front size. If you draw the net of the cube, this is how it will look like. Now, the total surface area is equal to the sum of areas of each of the 6 faces. You can see that each face is a square with a side x. Therefore, each face will have an area of x multiplied by x, and that will give us x squared. Because we have 6 faces, the total surface area will be x squared plus x squared plus x squared 6 times. And if you simplify that, you have 6x squared. So you say the total surface area of a cube is 6x squared, where x is the side of a face. Let's look at an example. Calculate the total surface area of a cube with length of side equal to 12 centimeters. In this question, we can just use our formula where we say the total surface area is 6 multiplied by the side squared. So if you do our substitution, then we have the total surface area to be equal to 6 times 12 squared. When we simplify that, we have 6 multiplied by 144. And that will give us 6 times 144. That is 864 centimeters squared. Let's look at another example. The figure is a cube with vertices A, B, C up to H, with BH equals 26 centimeters. Now the question is, calculate 1. The length of side AB correct to the nearest whole number. 2. Calculate the total surface area of the cube correct to the nearest whole number. Let's look at the solution. As you can see from the diagram, we need to find the side AB, and we can apply the Pythagoras theorem. First, let us represent the side with a variable x. Remember that the cube has all sides equal. We will start by finding the length of the diagonal in the base. From triangle ABD and applying the Pythagoras theorem, we have the length of BD squared equals x squared plus x squared. When we simplify this, we have BD squared equals 2x squared. Now, let's consider triangle BDH. Again, we apply the Pythagoras theorem, and we will have BH squared equals BD squared plus DH squared. We know our BD squared. So if you do a substitution, then we have BH squared equals 2x squared plus x squared. We have been given BH to be 26. So if you substitute, then you are going to have 26 squared equals 3x squared. Now 26 squared from our calculator will give us 676. And that is equal to 3x squared. We divide through by 3. So we have x squared equals 676 divided by 3. We are looking for the value of x. So we take the square root. And that will give us x equals square root of 676 divided by 3. Using our calculators, we have x equals 15.0111. We have been asked to write our answer to the nearest centimeter. So our AB is equal to 15 centimeters. Now the second part of the question is to find the total surface area of the cube. We have developed this formula and we know it is 6 multiplied by the side squared. So the total surface area is 6 multiplied by 15.0111 squared. And if you use our calculators, you have 1,352 centimeters squared. That's good. Now we look at the total surface area of a cuboid. Here are 3 cuboids showing their 6 faces. The areas of opposite faces are equal. We have one cuboid showing the top and the down sides. Another one shows the left and the right sides. We have another one showing the front and the back sides. Now you can see clearly that the equal faces have the same colors. And these colors are shown in the net of the cuboid. From the net of the cuboid, we can calculate the total surface area. Each area or each face is a rectangle. Therefore, the area for each face will be the length multiplied by the breadth. For one of them, you have the size to be x and y. So you have x, y, but because they are 2, you are going to have 2xy. Another face has x and z. So for those 2 faces, you are going to have 2xz. And the other one has y and z. So for those 2 faces, you are going to have 2yz. So the total surface area of the cuboid is going to be 2xy plus 2xz plus 2yz. And we can simplify that one to 2 multiplied by xy plus xz plus yz. This gives us the total surface area of a cuboid. Let's take an example. Calculate the total surface area of a cuboid of length 6 centimeters, breadth 10 centimeters, and height 8 centimeters. Let's look at the solution. We first draw a diagram illustrating a cuboid of size 6 centimeters by 10 centimeters by 8 centimeters. Our formula is given as total surface area equals 2 multiplied by xy plus yz plus xz. If you do the substitution, then you have total surface area to be equal to 2 into brackets 10 multiplied by 8 plus 10 multiplied by 6 plus 8 multiplied by 6. And that will give us 2 into brackets 80 plus 60 plus 48. If you use our calculators to evaluate that, then we have 376 centimeters squared. That was very good. Shall we take another example? Calculate the total surface area of a cuboid with square base of length 12 centimeters and height 15 centimeters. Let's look at the solution. We first draw a diagram to illustrate the cuboid, as you can see on the screen. Now we use our formula, which is total surface area, which is equal to 2 multiplied by xy multiplied by xz multiplied by yz. If you do a substitution, then you are going to have 2 multiplied by 12 multiplied by 12 plus 12 multiplied by 15 plus 12 multiplied by 15. And that will give us 2 multiplied by 144 plus 180 plus 180. If we simplify that, then we have 1008 centimeters squared. That was very good. Let's look at another example. A reservoir in the form of a cuboid with a total surface area of 1000 meters squared has its height equal to twice of length its square base. Calculate the height of the reservoir. Now let's look at the solution. Let x be the length of the square base of the reservoir. This implies that the height will be 2x, since the height is twice the length of the base. This implies that the total surface area is equal to 2 into brackets x squared plus 2x squared plus another 2x squared. And when you simplify that, we have 10x squared. From the question, the total surface area is given as 1000 meters squared. We can then equate these two values. That's the 10x squared and the 1000 meters squared. So you have 10x squared equals 1000. We try to solve for x. We divide through by 10, so you have x squared equals 100. Then our x will be equal to the square root of 100, and that is equal to 10. Therefore, the height of the reservoir is equal to 2x. With our x being 10, you have 2 multiplied by 10, and that will be equal to 20 meters. That was very, very easy. Let's now look at another type of prism. This time we are considering the cylinder. Let's consider a cylinder with height h and base radius r. The shaded portion are the circular part of the cylinder, and the unshaded part is referred to as the curved surface area. Now this cylinder is right because the base radius is perpendicular to the height. And it is circular because both the top and the base are complete circles of equal area. The total surface area of the cylinder is equal to the sum of areas of its parts. Let's now open the cylinder along its height and at the circular ends. The diagram illustrates what we are talking about. We are trying to open the top circular parts and then open the curved surface area. So you can see figure 1, figure 2, and figure 3. Figure 3 is the net of the cylinder. The rectangular part of the net is equal to the curved surface area of the cylinder. Now, from all that we have said, the circumference of the circular part is equal to the length of the rectangular part of the cylinder. You can remember that the circumference of a circle is equal to 2 pi r. Therefore, the total surface area of a cylinder is areas of the two equal circular parts and the area of the rectangular part. We know the area of a circular object to be pi r squared. Since we have two of them, we are going to have pi r squared plus pi r squared plus the curved surface area, which is 2 pi r h. When we simplify this, then we are going to have the total surface area of a cylinder to be 2 pi r into brackets r plus h, brackets closed. Remember that the curved surface area is given by 2 pi r h. Let's look at an example. Find the total surface area of the cylinder you see on the screen. It's a cylinder with circular base, radius 7 centimeters and height 15 centimeters. Now in this question, let's take pi to be equal to 3.142. Now our solution is, we first write down the formula for finding the total surface area of a cylinder, which is 2 pi r into brackets r plus h. If you do our substitution, then we have 2 multiplied by 3.142 multiplied by 7 into brackets 7 plus 15, brackets closed. If you use your calculator, we are going to have 43.99, that's the numbers outside the brackets, multiplied by 22, which is the numbers in the bracket, that is 7 plus 15. Again, if you use the calculator to multiply 43.99 by 22, then you are going to have 967.74 centimeters squared. That's very interesting. Let's take another example. The total surface area of a can is 408.46 centimeters squared. Find the diameter of the can. Take pi to be equal to 3.142. Let's look at the solution. The can you see is a cylinder. So you are going to use the formula for finding the total surface area of a cylinder, which is 2 pi r into brackets r plus h. In this question, you have been given pi to be 3.142 and the height of the can to be 8. And the total surface area is 408.46. So if you do the substitutions, then you are going to have 2 times 3.142 times r into brackets r plus 8. That simplification will give us 6.284 r into brackets r plus h to be equal to 408.46. We are solving for r. So we divide through by 6.284. And that will give us 65. If you open the brackets, you are going to have r squared plus 8r. So our final expression will be r squared plus 8r equals 65. This is a quadratic equation. And we have learned in our previous lessons that to solve a quadratic equation, you must equate to 0. And then you try to factorize, or you can use the calculator. Let's make an attempt to factorize the expression. That will give us r squared plus 13r minus 5r minus 65 equals 0. If you factorize, you have r into brackets r plus 13 minus 5 into bracket r plus 13 equals 0. Another factorization will give us r plus 13 into brackets, then r minus 5 also into brackets equals 0. We pick the two factors one after the other and solve for r. Solving, you have r equals 5 or r equals negative 13. Since r cannot be negative because the radius of a cylinder is r, therefore our r is equal to 5. Hence the diameter of the cylinder is 2r, which is equal to 2 multiplied by 5, which is equal to 10 centimeters. Now let's look at the total surface area of a triangular prism. These diagrams represent a triangular prism and its net. The net is made up of 2 equal triangles and 3 rectangles. Therefore, the total surface area is equal to 2 multiplied by area of a triangular face plus the area of the rectangular faces. So the total surface area is equal to 2 times area of triangular face plus the rectangular faces, as you can see, will be b multiplied by d plus a multiplied by d plus c multiplied by d. And you can simplify that to 2 multiplied by the triangular face plus, you can factor d out, and you have a plus b plus c. So the total surface area of a triangular prism is given by 2 multiplied by the area of a triangular face plus d multiplied by the perimeter of the triangular face. That's good. Let's take an example. Calculate the surface area of the triangular prism with sides 12 centimeters by 20 centimeters for the triangular face, 30 centimeters of the rectangular face, and a height of 9 centimeters. Let's look at the solution. Now, in the solution, we can easily find the area of the triangular faces, since we have been given the length of the base and the height. The only face which for now is impossible to calculate is quadrilateral BDEC. This is because we don't have the length of the side BC. Now from triangle ABC, we draw a perpendicular from point C to meet line AB at P. Using the Pythagoras theorem, we have AP squared plus 9 squared equals 12 squared. Simplifying this, you have AP equals square root of 144 minus 81. And that will give us square root of 63. Using our calculator, we have 7.937. This implies that BP is equal to 20 minus 7.937, which is equal to 12.063. Also, using the same Pythagoras theorem, we have BP squared plus 9 squared equals BC squared. If you do our substitution, you are going to have 12.063 squared plus 9 squared equals BC squared. When we simplify this, we have 226.515969 to be equal to BC squared. You want to calculate BC. So we take the square root, and that will give us 15.05 centimeters. We can now use the formula for finding the total surface area of a prism. Then we substitute the values that we have. And that will give us 2 multiplied by half, multiplied by 20, multiplied by 9, plus 30 into brackets 12 plus 20 plus 15.05. If you simplify for our calculators, we are going to have 180 plus 1411.5. Using our calculators again, we have the surface area to be 1591.5 centimeters squared. Let's look at another example. Calculate the surface area of the figure you see on your screen. Let's look at the solution. To easily calculate the total surface area of the figure, we have to find the length of the unknown parts of the right-angled triangle indicated in the diagram. We have shown this side with a red mark. We let that length be equal to x. Now we can apply the Pythagoras theorem, and from the diagram we will have x squared plus 16 squared equals 20 squared. That will give us x squared equals 20 squared minus 16 squared. That means we have x squared equals 400 minus 256. If you simplify that, we have 144. Therefore, our x is equal to square root of 144, and that will give us 12 centimeters. We now find the total surface area of the prism using our formula and substituting the values that we have. So you are going to have the total surface area to be 2 multiplied by half, multiplied by 12, multiplied by 16, plus 25 into brackets, 16 plus 12 plus 20. Simplifying that, we have 192 plus 25 times 48. And that will give us 192 plus 1,200. And finally, you will have 1,392 centimeters squared. That was very, very simple. I hope you keep on practicing with this formula so that you can always calculate the total surface area of a prism. Well, we have to end here. But before I leave you, let us take a quick look at what we have done in this lesson. In this lesson, we have learned how to calculate the area of a prism using the net. We have learned that the area of the net is equal to the total surface area of the prism. Well, students, we have come to the end of today's lesson. Join us again for our next lesson on volume of prisms. It's bye-bye from Uncle Ben.